So now that we've taken a look at putting together a simple implementation of a class, so we looked at implementing that rectangle class, and then also talking a little bit about the design phase that would go on just before we actually implement it. So we saw the UML class diagram that we would put together to specify the different fields and methods we would include in that rectangle class. I want to take a moment now to talk a little bit about some of the characteristics of the class that we've just written, and then also use this as a way to lead into another method that we want to go ahead and try to give our own custom implementation to. So we are working with what are known as instance fields and instance methods. So each instance of a class is going to be its own distinct entity. That means that essentially whenever we create a new object of a class, that is completely separate from any of the other objects of that class. This also means that each instance has its own data that is kept separate from those other instances. This data is going to be in the form of what we refer to as instance fields, and then methods that operate on this data are going to be referred to as instance methods. So the length and width that we created for our rectangle class, those are going to be instance fields because each object of the rectangle class will have its own unique, its own distinct length and width. Additionally, the methods that operate on that length and width, that is to say all 5 of the methods that we created, those are going to be instance methods. So that includes the get area as well as the get length, set length, and the get width and set width. So all 5 of those methods are instance methods. So we can see 2 examples right here. We've got 2 boxes that I've created on the left-hand side. One of those I call box, the other I call room. These are meant to refer to the reference variables of the rectangle class that will then point to or reference some rectangle objects that we actually construct somewhere else in the memory of our program. So in this case, we've got these 2 rectangle objects. For one of them, we're going to set its length to 5 and its width to 15. So that's going to be associated with that variable of box, essentially using the shorthand that I would typically go with for this. I would just say that the box object has a length of 5 and a width of 15. Same thing with the room object, or the object referenced by the room variable. This object is going to have its own unique length and width, a length of 16 and a width of 14. So if we wanted to, we could go ahead and include both of these in our program. So I'm going to actually go ahead and add these to that rectangle demo that we've been working on. So I'm going to go ahead and minimize this. I'm going to come back over to NetBeans, and we're going to keep the rectangle demo code open. So right here, I'm going to go ahead and construct 2 new objects of the rectangle class. So the code itself for rectangle, I don't need to change that in any way to do this. I'm just going to be using this as my blueprints to be able to construct more objects. So right here, we've already constructed 1 rectangle object that we call rect. So we're going to go ahead and make another one. So we're going to say rectangle. We're going to give it a new distinct name, so we're going to call this one box. This will be equal to a new rectangle. So we'll go ahead and call that constructor method to go ahead and make this new rectangle object. So at this point now, they already have their own distinct values, the rect and box variables that I created. Since rect, we're going to be setting its length and width to 10 and 5. With box, we haven't done that yet, so box is just going to hold the initial 0 and 0 that we specified right here. So what I want to go ahead and do is include some set length and set width methods to go ahead and modify the data inside of the box variable. So just like I did with the rect variable, I need to specify which particular object I'm going to be modifying. I'm going to go ahead and put that right here. I'm going to say box and then use that dot notation and then say that I want to access the set length method. So I'm going to go ahead and grab that. And then for this one, we're going to go ahead and set this one to 15 for the length. And then we'll go ahead and do the same thing for the width. So we're going to say box.setWidth, and we'll set that to 5. Okay. So at this point, we've got 2 distinct objects of the rectangle class. So we've got our rect object and our box object. The rect object has a length and width of 10 and 5, and then the box object has a length and width of 15 and 5. And then if I wanted to, I could go ahead and access all of these. So let's say that right here, I'm going to go ahead and put that in. What I'm going to go ahead and do is just grab these print statements right here. I'm going to go ahead and reuse those, but I'm going to be doing it with box instead of rect. So I'm I'm going to go ahead and paste that right there. And the two things I want to go ahead and change, the first one right here, I'm going to go ahead and change the print statement itself so that we can clearly distinguish between which ones refer to this rect object and which ones refer to this box object. So I'm going to go ahead and make it say box right here, just to make sure that that's very clear and very concise when you see the print statements in a moment. So do that for all three of them. And then the other thing I need to go ahead and do is right here, make sure that whenever I'm getting the length, width, and area, that I'm doing that for the box object. So I need to be very clear about exactly which object I'm interested in. So we're going to go change this to box. We'll go ahead and save this. And then if we run this program, we'll now see a few more print statements here. So we've got our length for the rectangle and the width for the rectangle, 10 and 5. The area is 50, so we've seen those before. And then the length of the box is 15, the width is 5, and the area is going to be 75, so it's going to be 15 times 5. And then if we wanted to, we could go ahead and add the room object as well. So let's take a look at including one more. So we're going to go ahead and make another rectangle object. So again, we're going to specify that the class or the data type for this object is going to be rectangle. I'll say this one's called room. This will be equal to a new rectangle. So again, we're going to go ahead and use the constructor to construct that rectangle object. And then we'll go ahead and right underneath where I set up the length and width of the box object, we'll go ahead and do the same thing for the room object. So we're going to do room.setLength. So let's go ahead and give this a length of 16. And then we'll do room.setWidth, and we'll give it a width of 14. So at this point now I have three distinct objects. I've got rect, box, and room. So each one of those has its own distinct set of sets for its data. So one for its length and one for its width. So rect is 10 and 5, box is 15 and 5, and now we've got this room which is 16 and 14. So then if I go ahead and come down here, I'm going to go ahead and just paste in those same three print statements that I've already copied. So I'm going to put them right here now. And for this one, we're going to do this for room. So again, I want to make sure that the statements themselves are very clear about which object I'm looking at. So I'm going to change rectangle here to say room. And then over here, I want to make sure that I'm very clear about which object I'm interested in. So which object am I trying to get the length, width, and area of? And in this case, it's going to be that room object. Okay, so I've now got three print statements where I'm getting the length, width, and area of rect, three more where I'm getting the length, width, and area of box, and then another three where I'm getting the length, width, and area of room. So if we run this, we can now see all 9 of these print statements. Just kind of expand this. So we've got the length of the rectangle is 10, the width is 5, and the area is 50. So I have those three statements. The length of the box is 15, the width is 5, the area is 75. So we've got those other three print statements. And then finally, the length of the room is 16, the width of the room is 14, and the area of the room is 224. So we can see each one of those, that last one being 16 times 14. So based on this, we can see, for each one of these different objects, each one's going to have its own unique or distinct pieces of data. So in this case, it was length and width. And then with the methods, so we've got specific methods that are unique to each one of these different objects. So to kind of add on to this idea of instance fields and methods, there's going to be another method that we're interested in that is very important about distinguishing between one object and another. And that's going to be the constructor method. So every time that you create or construct a new object of a class, you must call the constructor method. So we've already seen that before. So for all three of those objects we made, rect, box, and room, we had to call the constructor method. So you see rectangle rect equals a new rectangle, and that very last part where we have rectangle and that pair of parentheses. So that pair of parentheses is a reminder that we are calling a method. Specifically, we're calling the constructor method of this particular class, so the rectangle class. But there's a little bit of an issue with this, or something that's kind of funny about it. So if we take a quick look at the code for rectangle, So we can see we've got two fields for it, length and width. We've got 5 methods, get length, set length, and then get width, set width, and this get area at the very bottom here. But if this is all of the code for the rectangle class, where exactly is the constructor method? Well, we haven't actually written one for it yet. So if we haven't actually written a constructor method for it yet, how is it that we can call that method if it doesn't really exist? So you may have noticed that this method does not yet exist in the code for the rectangle class. What's actually going on here is that right now, because we have not explicitly written our own custom constructor method, we are instead going to use what is known as the default constructor. So the default constructor is going to be used if you do not write your own constructor. Whenever we call that default constructor, there are a few things that it's going to do automatically or kind of implicitly for us. That's going to include things like setting our numeric fields to 0, so like the length and the width. If we didn't already specify that those should be set to 0, this call to the default constructor would do that for us. Additionally, any Boolean fields that we use, those would be set to false, and then any other fields that are reference variables, so essentially any fields that deal with objects of other classes, those are going to be set to null. So a good example of that one would be if perhaps one of our fields was a string. So keep in mind that that strings are classes, or that whenever you create a string, that's an object of that class. So if you had something like that for one of your fields, that would be set to null initially. So in this particular case, when we're calling the rectangle's default constructor, that's going to make sure that the length and width are set to 0 if we didn't already do that. But perhaps instead of relying on the default constructor, we might be interested in making our own. So typically, we would probably prefer to just go ahead and create our own constructor. That way then we can go ahead and specify what the different fields should be set to initially. So whenever we first construct the object, we would prefer to go ahead and just specify what its data should be from the get-go. So it's not terribly different when you think about that blueprint to house analogy. You know, if you're going to go ahead and build a house from the blueprints that you've got, you probably want to specify certain characteristics about that house from the moment that you construct it. You don't really want to construct it as if it were just kind of this abstract nothing, and then from there start adding on to it. It wouldn't really make a lot of sense to do things that way. So to try to approach this in a way that seems a bit more useful and a bit more practical, we're going to go ahead and create our own custom constructor. So in this particular example, we're going to create a constructor that will accept 2 parameters. So we're going to be using this to specify what the length and width should be set to. This is going to be known specifically as a parameterized constructor. So that parameterized just means it has parameters. So we can see right here in this coding example that I've got, we still got our class header, public class rectangle. We've got the curly braces indicating the body of this class. I've got 2 comments at the top and bottom of that body to kind of indicate where the rest of the code should be located. So we've still got our fields at the very top, and then we're going to have all of the other methods. So ideally, the best practice for your constructor is to go ahead and put that at the top of all of your methods. So usually the constructor will be the very first method that you write. And we can see in this code, the constructor method, we've got that public keyword. So just like all of our other methods, the constructor should be public. Other classes should be able to access it. Admittedly, if you didn't make this public, it would be pretty useless, because then that would mean that you can't construct objects in other classes. That would kind of almost completely defeat the purpose of it. So we definitely want to make this public. We've got that. The next thing we're going to see is going to be the name of the class itself. So you might notice already we go from the access specifier public to the name of it, and there seems to be something that's kind of missing in between those, which would be the return type for this method. So an interesting thing about the constructor is that it never returns anything, and so because it never returns anything, we can't specify a return type for it. So we don't even say that it's void, we just never specify a return type. So the only 2 things that you're going to need for this part of the method header are going to be the access specifier and then the name of the class. So as far as the name is concerned, for a constructor, that name always has to be exactly the same as the name of the class. And again, as we know from the other relationship with the name of the file, it tells you that all 3 of those things should be exactly the same. So whatever you name the Java file, that's the same thing you have to name the class, and then that's the same thing you have to name the constructor. The next thing we're going to have is going to be that pair of parentheses. So this will be just like every other method where we've got our set of parameters as a comma separated list. So we've got two doubles for the parameters. One is going to be for the length, so we're calling that len, and the other one's going to be for the width. We're calling that wid. And so what we want to do is whenever we construct our object, we want to be able to pass in some values that we want to assign to the fields. So essentially, whenever we construct the object, we want some initial values for those fields. So the way that we can do that is by just passing in these two values here. So one's going to be assigned to len, and another that's going to be assigned to wid. So let's go ahead and take a look at the code and see if we can go ahead and add that to it. So right here we've got our rectangle class. Let's go ahead and close out this output for now. So coming up to the top, so just underneath the fields, at the very top of my list of methods, I'm going to go ahead and put in the constructor. So we're going to do public. So we'll have that public keyword. The next thing is going to be the name for this constructor method. That's going to match the name of the class, which also matches the name of the file itself. So we're going to say public rectangle. We then have that pair of parentheses, and then inside of that pair of parentheses, we're going to go ahead and put in our parameters. So for this one, we're going to be using two things. So we've got one double for the length, so we're going to call this one len, and then another double that's associated with the width. We're going to call that one just wid. We'll then go ahead and have our pair of curly braces for the body of this constructor, and inside of here what I want this to do is basically take each of these two fields, length and width, and we're going to assign to those fields whatever values len and wid happen to hold. So we're going to say length is equal to len, and we're going to say width is equal to wid. And you'll notice that this is very similar to what we do for our setters. So you're going to see right here, we're doing length equals len. That's very similar to what we did for set length. We also have width equals wid, which is very similar to what we do for set width right here. So again, we also see that same sort of pattern that I mentioned before. The color-coded text for the field, that's going to be on the left-hand side of the assignment operator, and then the black or the non-color-coded text referring to the parameters, that's still going to be on the right-hand side of the assignment operator. So once we have this constructor put together, we want to go ahead and take a look at another part of our code, which is going to be for step 5, where we were actually constructing our objects over in the main method. So we're going to go ahead and revisit step 5 with this newly created custom constructor that we have. So we can see some code right here. This is again using the tester class as the example in the slides. So that's going to refer to the rectangle demo that we have in our actual program. So we mentioned right here we're going to construct an object of the rectangle class, and we're going to give it a length of 10 and a width of 5. So when we first construct it, we're going to pass in those two values. So we see that we've got our rectangle rect equals new rectangle, and then in that pair of parentheses, we're going to see 10 and 5. So 10 is going to be assigned to len, and 5 is going to be assigned to wid, and we're going to be using those two parameters, the values that they hold, to initialize the length and the width, or at least initialize them when we construct the object. So let's take a look at this and see if we can add this to our program. So coming over here, so there's a bit of an issue that we're running into right now. It's kind of trying to give us a warning about the fact that we need to go ahead and specify this double, or this pair of doubles. So let's go ahead and do that. So right here for this first rectangle, that's referring to the 10 and the 5. So we're going to go ahead and put that in right here. So we're going to do 10, comma 5. So now whenever we first construct our rectangle object, we're going to be relying on the constructor method to set up the length and width for us. So that means we're not going to need these two lines anymore. So I'm going to go ahead and comment them out. And then to take a quick moment to really kind of explain the flow of the program as we do this. So we're making a call to the rectangles constructor, this rectangle method right here, passing in 10 and 5. So if we come over to our rectangle class, so we're calling this constructor right here, the constructor method, and we're using 10. So we're going to say double len is equal to 10, double wid is equal to 5. And then right here, we're going to take the 10 that len holds, we'll assign that to length, and then we're going to take the 5 that width holds and assign that to width. So then, as soon as we construct this object, length is going to be assigned 10.0 and width is going to be assigned 5.0. We'll go ahead and do the same thing for box and room. So box, this one was the 15 and 5, so we're going to go ahead and put that here. So we're going to do 15 for the length, 5 for the width. So now that we're doing that, we don't need these two lines anymore, so we'll go ahead and comment those out. And then finally for room, this one's going to be 16 and 14, so 16 for the length, and then 14 for the width. And once we're doing that, we can go ahead and comment these two lines out. So we'll go ahead and save this. And so now if I were to run this program, it's going to be using the different pairs of length and width values that I specified in the constructors for all of these other methods here. So if I want to go get the length, width, and area of rectangle, that's going to be based on the 10 and 5 that I put into the constructor. For box, it's going to be the 15 and 5, and for room, it's going to be the 16 and 14. So if we were to go ahead and run this, we would see that we still get the exact same output that we got before. We're just changing how we actually put that data into those objects. So we're doing it with the constructor method instead of relying on these set methods. And so this kind of helps to explain a little bit of a distinction between why it is that we might use the constructor or why it is that we might use the setters or the set methods. So we're going to use the constructors whenever we want to provide some initial values for the different fields of our objects. And we're going to be using these setters anytime that we need to change or modify those values. So if for whatever reason we need to change one of these two fields of our rectangle, so this rect object specifically, we can go ahead and use set length or set width on that rect object to change it to something else. So I'll go ahead and do just one example of this. So I'm going to go ahead and uncomment this one line, and let's go ahead and change this to something like 18. So the purpose here of set length is to just go ahead and change the initial value of rectangle's length, which was 10. We're going to go ahead and change that to 18. So now if I were to run this program, we're going to be using 18 for the length of the rectangle, so for the rect object. And then also if we get the area, it's going to be 18 times 5, so that's going to change to 90. So hopefully that kind of explains the distinction between these two kinds of methods, the constructor and the setters, and a little bit about why it is we might use one versus the other. Alright, so now that we've seen a little bit about the implementation of this, we also want to talk a little bit about how we would go about including this in our design process, so specifically in our UML class diagrams. So we can go ahead and now add the constructor method to that class diagram. Keep in mind that this method has no return type, not even void. So when we put it in, we're going to see this at the very top of our set of methods. So in that third section or that third component of our class diagram, you're going to see the public, so that plus sign, and then rectangle. So we've got the name of the class. That's also the name of the constructor. Then we have that pair of parentheses, and inside of that pair of parentheses, we have two parameters for it. So we've got len and wid. So now we can actually see a little bit about how this is put into our class diagrams. So for len, we follow the same syntax or the same convention as our fields. So we're going to say len, colon, and then its data type of double, and then a comma, and then we have wid, and then another colon, and then its data type, which is also double. And then unlike the other 5 methods, we don't have anything after that. So we don't have another colon and a return type because of the fact that constructor methods don't ever return anything, so they have no return type at all. So one of the things that you might have noticed whenever I was modifying this program, so if we take another quick look at it, was whenever I was adding these values to the constructors, if I went ahead and took these out, say like I removed the 16 and 14 here, when I do this I get an error. So if I were to try to double check to see what this error is, it's going to be telling me a little bit about how the constructor rectangle in this class cannot be applied to the given types. What it's trying to tell me, if we look at the rest of it, it's going to say required double double. That's trying to tell me what the parameters are over here. So it's telling me that, you know, this method is expecting 2 doubles, but what it found or what it saw right here when I called it was no arguments or just nothing. So the problem that it's running into is that the custom implementation of my constructor method doesn't match up with what I'm trying to do right here. But if you remember, when we didn't put that in, then this call to the constructor method where we don't specify anything was technically for the default constructor. So what exactly is the problem here? So we'll go ahead and undo that, leave this with no errors. So the problem that we're running into is that if you happen to write your own custom constructor, then you can no longer use the default constructor for that class. You can, however, write a custom Noargs constructor. So a Noargs constructor is kind of like the default constructor, at least in the way that it looks when you call it. The difference is that you've given it your own custom implementation. So we can look at something like the following right here. We're going to go ahead and make another constructor. So this one's not going to take any parameters or any arguments. Instead, it's just going to be that empty pair of parentheses. And then for this one, rather than trying to specify some passed-in values that we want to assign to length and width, we're just going to use some hard-coded values. So in this case, we can just go ahead and set it to 1 for the length and width. So let's go ahead and add this little bit right here, and then we'll take another look at using one of those constructors without any arguments. So go ahead and minimize this. Come over here. And so in addition to the parameterized constructor, the constructor that has some parameters, we're also going to add another one. This is going to be the Noargs constructor. So just above it, I'm going to go ahead and make a second constructor. So we're going to say public rectangle. This one's going to be empty, so there's no arguments here. And then we're going to go ahead and make the body of it right here. And for this one, we're going to take the length field. We'll initialize it to 1.0. And we'll take the width field. And we'll also initialize that to 1.0. Go ahead and save this. And now if we come back over to our rectangle demo, we could go ahead and take one of these objects that we created, and we can go ahead and remove the arguments we put in. So let's say we do this for rect right here. So if I go ahead and remove this and save it, so now when I initially create this rectangle object, its length and width are both going to be set to 1. So to really kind of see this, I'm going to go ahead and comment this line out for just a moment. So take a look at this. We'll run it. And so now whenever I'm getting the length, width, and area, so the length and width are both set to 1. That's because I used the Noargs constructor. So we're using this one right here on that rect object. And then of course when I get the area, that's just going to be 1 times 1. So that also just gives me 1. And then you'll also see for box and room, these are still using the parameterized constructor. So they're still going to have the same output they had before, 15,575, and then 1614, 224. Oops. So the general rule that I'm trying to follow here, since this method does not take any arguments, it is helpful to initialize the fields to some simple but still useful or practical values. So naturally, if you're trying to construct a rectangle object, it doesn't really make sense to have an initial length and width of 0. That's not really useful or practical when it comes to drawing a shape. So instead, we're going to go ahead and set it to a 1 by 1 rectangle. So in this case, a rectangle with the dimensions 1 by 1 will be constructed whenever the Noargs constructor is called. And then the last thing we'll go ahead and talk about with constructors is specifically addressing the string class constructor. So this one's going to be a bit unique to any of the other constructors. So you might recall some of the other classes that we've built or built objects with, things like the scanner, random, file. So in all of those cases, you always saw the new keyword and then a call to the constructor for that particular class. But with strings, even though string is a class, meaning that the things you assign to it would be objects of that class, you've likely never seen the use of the new keyword or something that would look like the constructor method for the string class. So since strings are used frequently in most programs, the constructor is set up in such a way that it can be implicitly called to reduce the amount of code that you have to write. So you can actually see the example right here where we're saying string name is equal to the string literal Joe Mahoney. So this is going to be an implicit call to the strings constructor. Alternatively, if you wanted to, you could actually explicitly call the strings constructor. So you see right here we've got string name is equal to a new string and then that pair of parentheses, and then we're passing in the string literal Joe Mahoney. But even though you can do this, that doesn't necessarily mean that you should do it. In fact, I would encourage you to never do this. You should not explicitly call the strings constructor. This is just excessive code to achieve the exact same outcome. So regardless of whether you do it implicitly or explicitly, you'd still get the same result. So why even add the extra code? The other problem with it is that it's going to result in constructing the string twice. So what's happening here is that even though you're making that explicit call to the strings constructor, you still had to put a string literal inside of it. And because you did that, that's also going to implicitly call the strings constructor. So that's going to duplicate the number of times that you make that particular string object. So don't worry too much about trying to explicitly call the strings constructor. There's pretty much never a good reason to do that. So at this point, this is going to wrap up everything for the constructor method. In the next video, we're going to take a look at adding on to the number of methods that we can include in our programs. Primarily, we're going to be taking a look at something that I did in this one by addressing why it is that I've got one constructor right here and then another constructor right here. So we'll talk a little bit about what's going on there in the next video.